Today I'm going to run through how a solar water heating system works, in particular a solar pool heating system. I will focus largely on evacuated tube heaters broadly at first and then more in depth with further quantitative analysis and explanations while also comparing this type of solar heater with a number of other alternatives. So just a little background to begin with. Solar collectors are becoming more and more widely used in pool heating systems due to their competitive costs over the lifetime of the system, as well as the environmentally friendly aspect that comes with this investment. In fact, solar pool heating is actually known to be one of the most cost-effective uses of solar power and can save owners thousands of dollars over time in energy costs. There are two main types of solar water heaters, flat plate collectors and EV tube heaters. A flat plate collector is shown on the right. It uses a sheet of highly conductive metal, usually copper or aluminum, which is painted black to transfer the sun's heat to an array of copper pipes which contain the heat transfer fluid. These systems are better for low temperature difference applications and are therefore common in southern locations. Evacuated tube heaters, on the other hand, work well in a variety of conditions, which I will dive more in depth into. Evacuated tube heaters are highly efficient at transferring the sun's energy into a form that can be used for heating water used within a home or swimming pool. The solar collector consists primarily of heat pipes, absorber plates or fins, evacuated or vacuum tubes, and a copper heat exchanger manifold. The solar collection system is then mounted traditionally to a rooftop with a galvanized or stainless steel frame. The insulation provided by the vacuum formed by removing the air from the tubes is so efficient, temperatures inside can reach 300 degrees Fahrenheit. This is what allows the system to work even in colder temperatures where flat plate collectors may fail due to heat loss. Evacuated tube heating systems are known to be more expensive and are therefore more well suited for commercial and industrial applications as opposed to residential settings, but have gained recent popularity for the heating of outdoor swimming pools. Alternatives to solar pool heaters include gas heaters and electric heat pumps. Gas pool heaters burn gas in a combustion chamber to heat water and are good for heating pools quickly for a short period of time, but can be expensive to use for regular use over long periods of time. Heat pumps, on the other hand, cost more than gas heaters but have lower operating costs. They do not actually generate heat, but instead use electricity to redirect temperatures and therefore can only operate above 45 to 50 degrees Fahrenheit. Both options have similar, if not slightly lower initial costs and necessary maintenance than solar, but have slightly higher operating or energy costs over time. Moving back to our solar heating systems, a common setup is shown in the diagram on the right. This setup consists of what is often polypropylene or PVC piping leading to a suction strainer to separate out debris before being fed into the pump. The pump drives the fluid, in this case chlorinated or salt water, through another filter before entering the solar collector, whether it be EV tube or flat plate. A number of check valves and flow control valves will be installed throughout the system as well to customize operation. Once heated in the solar collector, the hot water can be sent back to the pool or sent through a secondary conventional heater to ensure or expedite the heating process. This is a traditional setup, but obviously there are variations that can be made to suit each homeowner individually. Some important considerations to make when installing the system is first and foremost the sizing. Sizing is incredibly important when it comes to solar, as knowing the pool size, length of swimming season, average regional temperatures, desired pool temperature, site's availability of solar resources, the collector orientation and tilt, the collector efficiency, and the option of the use of a pool cover all come into effect here. It is also critical to note that initial quote-unquote capital costs will likely be higher than non-solar options, so financing and planning may be needed for startup. Lastly, the aesthetics of the system should be taken into account as well. Some find the look of solar appealing, while others find this to be a deal breaker when considering solar. This brief animation helps give a more detailed visual idea of the components that actually make up an evacuated tube heat exchanger. The aluminum or copper absorber plate is often covered in a selective coating that further aids the transfer of heat. The cylindrical shape of the glass tube allows the collector to absorb the sun's energy efficiently no matter the time of day or angle of the sun. The inner heat pipes are well insulated thanks to the vacuum properties, allowing for high temperatures to be reached. The manifold is the box where the cold water enters in and the hot water is sent out. It is insulated as well. There are both wet and dry forms of vacuum tube solar heat exchangers. Dry EV tube heat collectors keep the fluids housed solely within the manifold, while wet vacuum tubes utilize U-bends to move the fluid throughout the entirety of the solar collector. The same vacuum insulating technology found in popular thermoses, such as the Hydro Flask, is put to work in both types of EV tube heat exchangers, optimizing the use of the sun's rays. Due to the sealed vacuum within their design, evacuated tube collectors can get very hot, exceeding the boiling point of water during the hot summer months. These high temperatures can cause significant issues in an existing solar hot water system, such as overheating and cracking of the evacuated glass tubes. To help prevent this from happening in hot summer climates, bypass valves and large heat exchangers can be used to dump the excessive heat, as well as mixer valves which mix regular water with the hot water to ensure the temperature and pressure levels never exceed a preset limit. Other forms of care and oversight should be utilized when installing or performing maintenance on rooftops, as well as following local building codes and ordinances. The main difference between solar and gas or electric heating is the source of energy. Yes, a gas heating system may more quickly and consistently heat your pool, but it does not come from a natural and cost-free source like that of solar. The sun is never going to start charging you for its power, and therefore the energy costs will be limited to that of the cost to run the pump for solar pool heating applications. Traditional gas and electric heaters may cost anywhere from $300 to $500 per month for operation, whereas the cost to run the pump for a solar heater is likely to be closer to around $50 a month. This is where the cost efficiency between the two can be seen and the savings add up. Now, comparing efficiencies of tube versus plate heat exchangers can be a little more complex. In short, numerous experiments comparing the two have been run. Each show evacuated tubes to be around 20% more efficient overall in collecting the sun's energy as seen in the figure to the right. Further still, evacuated tube setups perform better in colder climates and withstand beatings from hail and thunderstorms significantly better thanks to their cylindrical shape. Therefore, EV tube heat exchangers, although not always the most cost-effective option, are the most efficient option in just about every case. Again, the largest difference between solar pool heaters and alternative forms of pool heating is the cost over the lifetime of the system. This can easily be seen by the be seen by the graph on the right. Solar heating systems are now very competitive at initial investment prices, but require little to no operation energy costs as touched on. This in turn can save the pool owner tens of thousands of dollars over the years, making competing options look almost obsolete. Further still, there is potential for solar tax credits in some states when installing solar heating systems. Solar pool heater collectors should be orientated to maximize the amount of daily and seasonal solar energy that they receive. The optimum orientation for a solar collector in the northern hemisphere is true south. However, recent studies have shown that a collector can face up to 45 degrees east or west of true south without significantly decreasing its overall performance. The angle at which a collector should be tilted varies based on your latitude and the length of your desired swimming season. Collectors for summer-only heating should be tilted at an angle equal to your latitude minus 10 to 15 degrees. For example, a collector placed in Nebraska would have an optimum angle of approximately 30 degrees. Collectors for year-round heating should be tilted at an angle equal to one's latitude. Evaporation takes a tremendous amount of energy in the form of heat. Therefore, swimming pools lose most of their heat from the surface due to evaporation. Because of this, the easiest known way to size a solar collector system is to base it off of the pool's surface area. The collector's surface area should equal approximately 60 to 100% of the surface area of the pool. For example, an 18 by 25 foot pool has a surface area of 450 square feet, so you can multiply this by 100% to be conservative and come to the conclusion that 450 feet squared of solar collectors should be enough to suffice. The addition of a pool cover can greatly improve the heat loss and therefore allow for a smaller size collector as well. These sizing approximations actually find their roots in basic heat transfer calculations. The heat energy equation being mass flow rate times heat capacity times the temperature out minus the temperature in can be used to explain the heating process. An example is shown below in which an EV tube solar collector is used to heat 2 kilograms per second of water from 24 degrees Celsius to 55 degrees Celsius to effectively heat a pool. The sun radiates approximately 1,000 watts per meter squared. Using this and also the equation, Q equals the overall heat transfer coefficient times area times the change in temperature and an average efficiency of 75%. The size of the system needed can be determined. The pump can then be cycled to maintain the desired temperatures. So in conclusion, solar collectors are an effective form of pool heating, especially if initial installation financing is available, as the payoff over time is proven. Evacuated tube heaters are highly efficient thanks to their shape and vacuum technology, which insulates the heating process. Sizing can be tricky, but advances in software based off prior installation experience and basic heat transfer calculations can help to optimize your setup. Solar EV collectors have become so commonplace they can even be found on Amazon as shown and are likely to become more and more normal as technology and green energy advances with time. So here are the references used to create the video. This video was created with knowledge acquired over the course of Chemical Engineering Transport Operations 2 at the University of Nebraska. Thanks.